Okay, we have question 3. Consider these two vectors. A is equal to 3i minus 3j, so that's positive x direction, negative y direction. B is equal to negative I minus 4j, so negative x and negative y directions. Calculate vector C, which is just a plus b. Okay, so for C, I need to take the components of A that are in the x direction and add them together. I need to take the components of B that are in the x direction, add them together. I need to do the same thing for y. Okay, so if I want to write this out fully, I'd have A plus B. I'm going to have 3i minus 3j. This whole thing is plus negative I minus 4j. Okay, and then I'm going to combine the like terms. So I have a positive 3 and a minus 1. If I add 3 plus a negative 1, I'm going to get 2 left over, and that'll be in the I direction. And then I have a negative 3 plus a negative 4. So a negative plus more negative gets me a minus 7j. Okay. So that should be our vector C. This is part A plus C. For part B, calculate what A minus B is. And they want that as vector D, so A minus B. So we do the same thing. We'll have 3i minus 3j minus negative I minus 4j. Okay, so now I have a 3i minus a negative 1. Okay, minus a negative is going to make it go back to positive, so we're going to end up with a 4i to combine our like terms. And I'll have a negative 3 minus a negative 4. Okay, so this is going to be a negative 3 plus 4, so that gives us a positive 1. So we will have for our D vector 4 plus j. 4i plus j. Okay. For part C, it wants to calculate what the magnitude of C is and the angle from that x-axis. So for part C, we already have vector C. I just need to figure out what the magnitude of C is. And to do that, we can use Pythagorean theorem and square its components. So the first component here is going to be a 2. And then plus this negative 7 squared. All underneath a square root because it's Pythagorean's theorem. And we'll go ahead and we'll plug that in and see what we get. Okay. And it looks like I'm getting 7. Let's go 7.3. Okay. This one didn't specify units. There's no units attached to it, so magnitude of C here would be 7.3. Okay. And then same thing for D. We're going to calculate out what D is. So magnitude of D would be these ones. We'll have square root. We'll have the first number, which is 4 squared, plus the second number, which is just 1 squared. Okay. And for that one, we'll get square root of 17. Square root of 17 is going to give us 4.1. Okay. I'll go ahead and put it like that. All right, so that's A, B, C, D. We're still missing, though, the angle. I need to calculate what that angle is from the x-axis for both C and D. So let's do a little side work over here. I'm going to draw out what C looks like. Okay, so I'll have 2 in the positive I, or the positive x direction. And I will go down 7. Okay, so this is 2i, and this is 7j. Okay, so that vector looks something like that. Now this wants the angle from the positive x-axis. Well, this is the positive x-axis, so we just need to find that angle there for part C. So I have the x, or the let's see, the adjacent, and I have the opposite. I do not have the hypotenuse. So hopefully, if you know SOHCAHTOA, you know this must be a tangent. So let's see, if we have tan of the angle, which is what we're looking for, that is going to have to be equal to the sorry, SOHCAHTOA. It's going to have to be equal to the opposite, which is going to be 7 over the adjacent, which is 2. So to get tan by itself, we want to take an inverse tan. So for that, we'll get theta is equal to tan inverse of 7 over 2. And let's see what we get. We do a tan inverse 7 over 2. And we get a theta. I'll put it down here. Theta. If you plug in your calculator correctly, we get 74 degrees. And we have to specify, I'm going to say that that is below positive x-axis. Okay, 74 degrees below the positive x-axis. Now, does it look like about 74 degrees? It is pretty sharp heading down, so I would assume that we're okay. We're going to do the same thing for D. Let me draw D out. We have 4 in the positive x direction and 1 in the j direction. Okay, so that's what D looks like. We have 4 and we have 1. And we're looking for this angle in here. Same scenario. We have a tan of our angle is going to be equal to SOHCAHTOA, so it's the opposite, 1 over 4 over the adjacent 4. It's the same scenario. To get theta by itself, we take an inverse tan, tan to the negative 1 of 1/4. Okay. And if we do that, what do we have? We have 14 degrees. So that's pretty small. That looks probably about right. I'm going to add that onto this one. Theta is equal to 14 degrees above positive x axis. Okay, so these can be included in our boxed answer. And there we should have everything for this problem.